Okay, so I'm covering the power rule for exponents today, and this is a very important rule that I actually see a lot of people get wrong. So it is important to know, and we're covering lots of rules for exponents this week. These rules are needed for when we're multiplying polynomials because we usually end up having to multiply things with exponents together. It's also used when we're factoring next week because we ending up dividing polynomials by things. And so you have to use the division rule when you're working with exponents. And so these rules seem simple once you kind of understand how they work, and they're really important. So just as some background definition stuff. So we're going to be working with exponential expressions. So first we've got exponent. So an exponent is repeated multiplication. And our definition of an exponent is that if you have any number to some exponent, positive integer, positive number, although we will kind of look at, you could have negative numbers and you could have 0 there as well, but it's just, you're just multiplying the base, which is the thing under the exponent, multiple times, and the number of times that you have for that exponent. So when we say we are working with exponential expressions, so an expression is something without an equal sign. So basically any kind of math that you see where there's no equal sign is an expression, and an exponential expression just means that there are exponents present in what you're looking at. So when we're simplifying or evaluating these, we're still following the order of operations. We do have specific rules when we're simplifying the variables. And again, those still follow the order of operations when we're simplifying with the variables. So there are two basic rules that are just the arithmetic when you're doing arithmetic, and arithmetic is multiplication, division, adding, subtracting. So when we're multiplying or dividing things involving exponents. So when you're multiplying, as long as the base, which is the thing under the exponent, is the same, when you're multiplying them together, the exponents add. And when you're dividing things where they have the same base, but they have exponents on it, you subtract the exponents. So I do have a video that goes over each of those separately, but that is just some basic rules that you're adding when you multiply exponents and you subtract when you divide exponents. So today we're going over the power rule for exponents. And this is basically when you have an exponent on something that already has an exponent. And so the rule is that you multiply the exponents. So if you have an exponent on top of an exponent, the exponents multiply together. So this rule follows from the multiplication of things with exponents. So let's say, for example, I have 2 cubed, and then that whole thing is to the 4th. So the outside exponent of 4 is telling us that our base 2 cubed is multiplied 4 times. So we have 2 cubed times 2 cubed times 2 cubed times 2 cubed. So you're kind of working outside in when you're dealing with exponents. Now, the 2 cubed multiplied 4 times, that we can use the multiplication rule where you add the exponents together. So those things are multiplied, exponents add. So that's 2, and then you add all those 3's together, 3 plus 3 plus 3 plus 3, and that adds up to 12. So this becomes 2 to the 12th, which is the same thing as if you actually multiplied those exponents. 3 times 4 gets you 12. So if we didn't have the power rule for exponents, you'd have to actually rewrite the multiplication of 2 cubed 4 times, then use your multiplication rule to add those exponents. With the power rule, we can skip those 2 steps and just multiply those exponents together. So it's really nice. It saves you a couple steps, and it follows from what we've been doing previously. It's just, we notice this pattern. This is always going to be this case. So we can make a new rule for it. So that's the power rule. So I will often say that the exponents distribute. they kind of, because you've got something in parentheses and then something not, and they get multiplied. That's sort of what we do when we have just the distributive property, is that you have things in parentheses and out and they multiply. So I've got 4 examples here. And this is such a simple rule that I only have a few examples of each kind. And then I'm going to have a couple of sort of conceptual things to kind of show you what happens if you have, if it's slightly different, like if you don't have parentheses. Excuse me. So simplify. And when you see the word simplify, it means, okay, if you have things with exponents, you want to try to follow the order of operations. So we want to try to, instead of having multiple exponents, we want to have one exponent if possible. And then when it says write the answers in exponent form, that just means that if you have some number to an exponent, don't find out what that number is equal to, just leave it in the form with the exponent. So top left, we have 2 to the 8th and then to the 7th. So the rule, the power rule, says you just multiply those exponents together. So I'm going to show that step, actually write it out. It's 2 to the 8 times 7. And you want to make sure that you use a dot for multiplication, because we're working with variables. So you want to get out of the habit of using an X. We use a dot for multiplication. And so you multiply those exponents, 8 times 7, which I think that's 56. That's, for some reason, one that I have a hard time remembering. So I'm going to just double check on my calculator. Yeah, 56. So this is 2 to the 56. And that's how our final answer. We're not actually going to figure out what that number is equal to, because it's going to be giant. So when it says leave it in exponent form, you just leave it with that exponent. You don't actually evaluate and find out what the number is. But you're just, the power rule says you're just literally multiplying those exponents together. So it applies if you have the number 2. It also applies if you have variables. So it can work with numbers, it can work with variables. So on the right, we have z to the 6th and then to the 4th. So this is equal to z to the 6 times 4, which 6 times 4 is 24. So this is equal to z to the 24th. So pretty simple. You're just multiplying those exponents together. So before I move to the 2 on the bottom that are a little more complicated, do you have any questions? Okay. So bottom, these are a little more complicated. They don't really look like the ones on the top. So on the left, we have z times z cubed and then squared. So our rule has one thing inside the parentheses. And here we've got 2 things. We need to follow the order of operations. So order of operations says P, parentheses, comes first. This means we need to simplify what's inside the parentheses before we deal with the exponent on the outside. So we have z times z cubed. So we need to simplify that by using that multiplication rule that we have. So if you see a variable with no exponent, it means there's an exponent of 1. So this is really z to the 1st times z cubed and then squared. So we add the exponents on the inside to simplify. So this is the parenthesis step of order of operations. You're simplifying inside there. And so we're combining it to a single z. 1 plus 3 is 4. So we get z to the 4th and then squared. Now, because a lot of people get confused, they start adding or they multiply when they should be adding and all of that, it might be worth writing down that it's 1 plus 3 before you write z to the fourth, just to show a few extra steps, or maybe writing down it with words, we're multiplying, so exponents add, and then we've got a power, so exponents multiply. Just something to help you remind you when you add the exponents, when you multiply exponents, because they do tend to get confused, and I've seen people do them in the wrong order. Basically, they multiply when they should add, they add when they should multiply. So, whatever note you have to leave for yourself in your paper to kind of explain what's going on, that's important. So order of operations, we did what's inside the parentheses first. We've simplified that. So now we've just got z to the fourth inside. Now we can do the exponent part of the order of operations, which means you're multiplying those exponents together. So 4 times 2 is 8. So you get a final answer of z to the 8. So what I really want you to realize is that everything we do still follows the order of operations, even if it has variables. So, we had to simplify inside parentheses before we took care of the exponent stuff. So just keep that in mind, that even if it doesn't look like the typical order of operations problems, we're still following the order of operations. It's just, it looks a little different. What we do when we do the parentheses step or the exponent step is a little different with variables, but we're still going through that same procedure over and over and over again. So example on the right is done basically the same way. And I could have had, I don't have to have a 2 on the outside. I could have any exponent there, but I've got y cubed, y to the fourth, and then that's in parentheses, and then the 2. So notice the one on the left, I put a dot for multiplication. You're not required to do that. You can also just put them next to each other. That's also assumed that you're multiplying them together. So I just want to show both ways. So we're adding our exponents. And so you might want to actually write that out, because we're doing the inside of the parentheses first. 3 plus 4. So you're adding that exponent together. So if it helps, you can actually write that. So that gives you y to the 7th, and then you have the exponent on the outside of 2. And so we've simplified inside the parentheses. So now we're going to do the exponent. So we're going to multiply those because we want one exponent. We don't want an exponent on top of an exponent. So 7 times 2 is 14. So you get y to the 14. There are questions. Okay. So just as a side note, I mentioned that I will say it's kind of like you're distributing the exponent. Notice that, I wrote y and then 3 plus 4. If I had multiplied the 3 by 2 and then the 4 by 2, kind of distributed that outside exponent onto the inside, you would get 6 plus 8. When you actually did that multiplication, that also gives you 14. So you'll get the same answer if you kind of did the exponent and then kind of combined them. So that doesn't always work with normal order operations, but for something like this, it does work. You will get the same answer if, you can kind of distribute that 2 and apply it to the exponent separately and then combine. But, if you want to make sure that you're following the order of operations, you would simplify inside first. So now these are the 2 that are going to be kind of conceptual, and just to kind of show you how order matters, parenthesis matters, or whether it doesn't matter, that sort of thing. Because, math is very particular, and whether you have parentheses or not matters. It makes a huge difference in what you're interpreting and what it means. So evaluate means you're actually going to find the number answer for this. And then comparing the answers. So when you're asked to compare, that means you're going to be writing in words. Is it larger, smaller, the same, that sort of thing. So the first one we have is 4 to the 4th and then squared. And then we're going to compare that to 4 squared and then to the 4th. So the exponents are just in different orders, basically. So if we have 4 to the 4th and then squared, so the power rule means you multiply those. That's 4 times 2. So you get 4 to the 8. And so it says evaluate. Evaluate means you want to actually find what that's equal to. So you want to put that on your calculator. And that comes out to 65,536. And you can enter that in your calculator, making sure you have parentheses in the right spot, and you will get that same answer if you just put in 4 to the 4th and then squared with the parentheses in the right spot. You'll get the same answer. So 4 squared to the 4th, that would be 4 to the 2 times 4. We get the same answer, 4 to the 8th. And so these are equivalent. So evaluating is getting the actual number answer. We have 65,536 for both of them. Comparing is what are you noticing? So what we're noticing, what you're seeing is that these are the same thing. So we call them equivalent expressions because they are equal. So these are equivalent expressions. And why did we get the same answer? It's because the power rule is multiplication, and the order of multiplication doesn't matter. We learned that we have the commutative property of multiplication. Order of multiplication doesn't matter. So whether we do 4 times 2 or 2 times 4, you get the same answer. So these are equivalent expressions. This is because the order of multiplication doesn't matter. So just something to note that these exponents, you can flip them around, you'll get the same answer when you've got like when you're using the power rule. Now, the second example here, these are almost exactly the same, but there's parentheses in one of them and not in the other. So we have 3 to the 5th to the 2nd, and then 3 to the 5th to the 2nd, but we've got parentheses in the second one. So how do we evaluate these? So we'll start with 3 to the 5th to the 2nd. Order of operations says you do parentheses first. We don't have parentheses. It says next is exponent. So we always work the exponents outside in. So the order of operations says that you're going to do 5 squared first, because we're always work our exponents outside in, sort of like parentheses, you work inside out, exponents the other way around, outside in. So you do 5 squared first, and then we would do 3 to whatever that is. So 5 squared is 25. So it's going to be 3 to the 25, which my calculator, I don't even know if it can give me the answer. Giant. So I'm going to just leave it as 3 to the 25. Evaluating would give us some number. It's times 10 to the 11. It's really, really big. Now, next one. Three to the fifth, and then parentheses, and then square. So here, the parentheses are telling us with the order of operations that you actually want to do 3 to the fifth first. So if we were evaluating this, where it's like we're doing 3 to the fifth, and this is the power rule. We can use the power rule to do this, where you multiply those exponents, but I'm just going to kind of show what you would be doing if you're really evaluating. So actually I should write what this one's equal to. 3 to the 25. 8.47, about, I'm going to round, times 10 to 11. So giant number. If I did 3 to the fifth first, so I'm going to just do that on the calculator. It's 243. So that's 243, and then your exponent is squared. So you square that number, you get 59049. So 59,049. So, and the power rule would say that this is 3 to the 10 if you want to compare, because the power rule says that you multiply these exponents first. So it does 5 times 2, which would give you 10, and then you do 3 to the 10. So we get different answers here based off of order of operations, because one has parentheses and one doesn't. And so when you have your comparison, 3 to the fifth to the second is larger than 3 to the fifth, and then that squared. So we get a larger answer. And this is just because, one, the parentheses are telling us to make sure that you do the inside and then the out, use that power rule. The other one, it's not writing it like the power rule. So it means something different. And so you do the order of operations differently. Now I will, as a caveat, so I don't know if you guys are familiar with, there are different ways that calculators do math. There's actually, my dean was just asking me about this last week. There's something called reverse Polish notation, where some calculators do like things with exponents in a slightly different order. So my calculator, and it may be different based off of what calculator you have, how it evaluates it, but my calculator, if I put in the first one just as written, 3 to the fifth to the second, it assumes the second one, and it will give me the second answer. So just as a little side note, so my calculator, and your calculator may be different, sees 3, 5, 2, and assumes 3 to the fifth and then squared. So just a little side note there, because it is, the top one is very ambiguous, because you've got 5 squared, so you really got an exponent of 5 times 5, versus in the denominator, or the second one, we've got, 3 to the 5th written twice, and then you get an exponent of 10. So you're never, so because calculators can do this particular one a little bit differently, just because sometimes depending on how it's coded, it does exponent slightly differently. We will always put parentheses to make it clear which one we want. So if, instead of having no parentheses here, you might see the 5 squared in parentheses saying do that first and then, do 3 to the 25th versus the parentheses around the 3 to the 5th and then square. So generally we don't write 3 to the 5th squared because it's a bit ambiguous on which order you want to do, and calculators interpret it differently depending on how the calculator just happens to be coded. So I just wanted to do this second one here to kind of point that out about the interpretation, how parentheses are really important, and just to be aware that you have to understand how your calculator does the calculations so that you know if it's doing what you intend it to do, basically. But we're never going to give you something like 3 to the 5th to the 2nd without parentheses just because of its ambiguity on, like, how do you interpret that? What order do you do? So are there any questions on either of these two examples? Okay. That's all I've got then for this.